Today we're going to talk about normal distributions and we're going to practice finding z-scores in areas with TeX. We're going to do a practice problem and then we're going to talk about assessing whether or not something is normal. This version is for the TI-84. These are the directions for how we find area using data. So go ahead and pause and write this down, and then on the next slide I'll show you how to do this on the 84.
Okay, so on the TI-84, we're going to be in this thing here that says distribution or distra. So we're going to hit second bars, and we have distribution and draw. The draw isn't that great, so we're just going to deal with distribution. So we're going to use normal CDF. It's the second one down. Do not use PDF. That we will never use that one. We will only ever use CDF because CDF is a range of values. So then I need to hit enter. And let's do the one that we did with gerbils, looking at less than 20 grams, what gerbils weigh less than 20 grams. So they have this defaulted here to -1 times 10 to the 99th. As long as it's a negative number with 1 and a lot of zeros, that's fine. So I'm going to say that's my lower. My upper is 20. My mean is 25. My standard deviation is 3. And then I'm going to hit paste. And paste is going to put it there on my home screen. And then I'm going to hit enter, and it's going to give me the percentile, which is 0.477.
So now that you've done your calculations with your calculator, you need to show your work. And I'm going to tell you that, yeah, your calculator can do it, but you need to show how you got a z-score every time. So I need to say, okay, my value was 20, my population mean was 25, the standard deviation was 3. Now I don't have to say what the z-score was. I can just leave it like this, but you best believe that you've got to have a distribution. So 25, 20, and then I need to shade what I want, which is less than 20. And then I need to explain how I got this. So I actually need to say, using TeX, I did a distribution, and for my distribution, I did a normal CDF, and I said my lower was some negative and a bunch of zeros, and my upper was 20. My mu was 25, and my standard deviation was 3, and then I need to say, the percentile that I got for this was 0.048. So that is me showing all of my work. So then this is how we would find an area or a percentile if we're given z-scores instead of actual values. So if we're given z-scores, again, it's going to be the same thing that we did before, only we're going to enter mu as 0 and sigma as 1 because that's the standard normal distribution. And since we're using z-scores, we now have a standard normal distribution. So I'll give you a sec to pause so that you can write these instructions down.
Okay, so this time I need to find an area from a z-score. So again, I'm going to be in distribution here. So second bars, and then I'm going to normal CDF just like I was before. My lower is the same, negative, basically the highest number I can think of. And then instead of 20, we're going to enter in our z-score. So negative 1.67. And because this is z-scores, I'm talking about a standard normal distribution here. So when I have a standard normal distribution, my mu is always 0. And when I have a standard normal distribution, my standard deviation is 1. Because it is standard normal, it's a distribution of the z-scores. So then I'm going to hit paste. and then enter again. And then, oh, look, I get the same answer. So this is my area again, 0.047, if I had used a z-score instead. So again, I don't have to use z-scores to find area. I can use my actual values instead. So we're going to try one more time. We're going to go to distribution. So I'm going to hit second bars, and I'm going to go to my normal CDF again and hit enter. And let's say I want to find between two values, like between 20 is my lowest and 26 is my highest grams for gerbils. So I know, again, because I'm just using my actual values, I have to use my mean of the population and the standard deviation of the population, not my standard normal, but my just normal distribution, so 25 and 3. And then I'm going to hit paste and hit enter, and then it gives me the percentage of gerbils that weigh between 20 and 26. So what we're going to talk about now is how you could use the calculator to find a z-score, and I'm going to be really honest about this. Mostly I use the table for this one, but essentially what we would do, we would go to second vars and we would go to what's called the inverse normal. So from going, essentially what that means is going inside the table and then going out. And I would enter my area and then enter mu as 0 and my sigma as 1 in order to give me a z-score. But I can also find, I don't have to use, I don't have to find a z-score. I can actually find an actual value using the normal distribution instead of standard normal. And I'll talk to you through that as you do the calculator. This tail is something different on the 84CE. Basically, it means that, hey, what are you looking for? Are you looking for something that is talking about an area this way? Well, then that means your tail is to the left. Are you talking about an area that's this way? That's tail to the right. Are you talking about something that's in the dead center? Then that's the center. Okay, so to find the z-score, we're going to be in distribution again. That's where we're living today. So second vars, and now we're at inverse normal, because again, we're going from the inside of the table out to try to get a z-score. So inverse normal is what I'm going to hit. And then let's say I have a percentile of 90% and it's shaded to the left. So I'm going to say 0.9 and I want the z-score. So my mu is going to be 0, my sigma is 1, and I'm going to say, hey, my shading is to the left. And I'm going to paste that, and I get a z-score of 1.28, which makes sense. 90% of the data should be that in my z-scores. Now, I don't have to do a z-score. I could find an actual value. So maybe I want to find the actual weight of how many grams does a gerbil weigh that weighs more than 90% of gerbils? So I would be like, okay, well, the mean is 25. The standard deviation is 3, and I want to know that this gerbil weighs more than or equal to 90% of the gerbils. So I would say left and arrow down to paste and hit enter, and then I get the actual value. Well, that gerbil weighs 28.8 grams. So a gerbil that weighs 28.8 grams weighs more than or equal to 90% of gerbils. What's cool about the TI 84CE, which is different than the 89, is this tail thing. So I could actually be like, well, what is the weight of gerbils that is 10% of gerbils weigh more than it? Okay, we should know this answer because, hey, we just did it. We just did it with 90%. 0.9 plus 0.1 is 1. But I wanted to show you kind of how this tail things work. So in this case, I'm saying 10% of gerbils weigh more than this. What value is the weight of this gerbil? So now I'm saying that 10% is on the right-hand side. So I'm going to hit enter there, paste, and I should get the same value, right? Because 0.9 plus 0.1 is 1. So it's 28.8. So what's cool about the 84 is that it can do both of these.
So what have we done so far? The answer is a lot, and we're almost done with the chapter. So this is what we've done so far. First we were able to find an individual's percentile. Then we could turn that into a cumulative relative frequency graph, which is a graph of the percentiles. Then we learned how to transform data, how addition, subtraction, or multiplication or division are affected, how they affect shape, center, and variability in a distribution. We learned how to locate an individual in a distribution using a z-score. So we learned how to make z-scores and the formula for that. We learned the 68, 95, 99.7 rule, aka the empirical rule, to estimate normal percentiles. Then we learned about standard normal distribution. So basically, we learned about the fact that I can have a distribution of z-scores, and then my mean is 0 and my standard deviation is 1 when it's standard normal, aka z-scores. We learned how to use table A to turn a z-score into a percentage, and we did that with tech as well. And we also learned how to use table A to turn a percentage into a z-score, and we learned that with tech as well. So let's try an example of this. This was actually the first statistics teacher at Holy Names did this for me when I was pregnant, so that she actually wrote this problem about me, which I love. So a pregnant woman is due in January. She has asked the stats class to help her estimate the length of her pregnancy based on the average length of pregnancies. The approximate normal distribution of pregnancies from conception to birth has a mean of 266 days and a standard deviation of 16. Might she give birth early? This was my big question. What percentile is a pregnancy that lasts 8 months? Might she be about on time? What percent of pregnancies last between 8 and 9 months? And then I was very specific there. And then might she be late? How long did the longest 20% of pregnancies last? These were all very important questions to me. So let's take each one at a time. So let's take the problem of might she give birth early? What percentile is a pregnancy that lasts 8 months or 240 days? So let's start with what we know. We know that the mean is 266. We know that the standard deviation is 16, and we got that from the previous slide. Okay, so the first thing I want to do is I want to draw a distribution. So I want to go, what's the possibility that could be less than 240? So my x value is 240, and I want to know what's less than that. So I actually took a picture because it's easier for that than drawing. So this is what I'm looking at here. So this is what my distribution would look like. So first step, write down what we know, then write our distribution. Then we need to come up with a z-score. So we're going to say, okay, our z-score is going to be 240 minus 266 divided by 16. And when I do that, I get a z-score of negative 1.63. So I need to find what the percentile is for z-score that is less than negative 1.63, because that's what I shaded in. So I'm going to show you how to do this on the table. So let me bring the table up here. So I'm going to find my z-score of negative 1.63. So I'm going to go to negative 1.6 and 3, and so that looks like this to me. So 0.0516. Okay, so if I were to answer this in context, I would say about 5.2% of pregnancies last less than 240 days. which to me meant, dang, I am probably not going to be early. Okay, so let's take a look at this second problem. Might she be about on time? What percent of pregnancies last between 8 and 9 months, between 240 and 270 days? So first thing I need to do is write down my givens. Mu equals 266, and the standard deviation is 16, and x, my first x is 240, and my second x is 270. So I would probably pause and be like, wait a second, what am I doing here? I better draw a distribution. There it is. So it's between 240 and 270, which means I'm going to need 2 z-scores and 2 percentiles. Luckily, we've already done 240. 240 we found had a z-score of negative 1.63, and then we found that the percentile for that z-score being less than negative 1.63 was in fact 0.0516. So we've got info for there. We need to do 270. So we're going to do a z-score for 270. So we're going to say, okay, that's 270 minus 266 divided by 16. And that gives us a z-score of 0.25. So I'm going to look at my table and look at 0.25. So looking here, I have 0.25, hey, right there, 0.5987. So that equals 0.5987. Now I'm not even close to done. That is all of this region, right? And I know that 0.0516 is all of this region. So I'm going to have to subtract 0.5987. I'm going to have to take away from that 0.0516. So when I do that, I get 0.5471, or roughly 55%. So I might be like about 54.7% of pregnancies are between 240 and 270 days. So C is a bit of a tricky one. Might she be late? How long do the longest 20% of pregnancies last? So, okay, let's figure out this one. Again, I can do this. Mu equals 266. My standard deviation is 16. And now I have a percentile. I have 20%. So the first thing I'm actually going to do is draw a distribution here. So I want to say the longest 20%, which means that's 20%, but on the right side. And I can't do anything unless it's on the left side. So I have to do my fun math and go, okay, well, 1 minus 0.2, that's easy, that's 0.8. So what I'm really looking for is a percentile of 0.8 is what I'm going to need to calculate. So I'm going to go inside the table. I'm going to show you how to do that on the table. You're welcome to try your calculator. So on the table, I'm going inside, and I'm looking for 0.8. So this is pretty close. 0.7995, that's pretty close to 0.8. So if I go backwards here, I see that I have 0.8 and I have 0.04. So that's going to be 0.84. So the value for my z-score is going to be 0.84. Now I showed you how to say that you were doing this with TeX. If you're not using TeX and I just say this, they don't know how I did this. So I need to say that I'm using table A. Using table A, I got this z-score. Well, that's great. I want to know what the longest amount of time is, though. So that, all I have is a z-score. So now I need to solve for my value. So I'm going to set my z-score equal to the formula of value right? Minus my mean, 266, divided by 16. So I'm going to multiply both sides by 16, and this side is going to be 13.44, and this side is going to be x minus 266. Okay, so now what I've done is I'm going to add 266 to both sides. So that's going to be, let's see, x equals 279.44. So then I could write this in interpretation. The longest 20% of pregnancies last approximately, look at me abbreviating, 279 days or more. Which was 100% the case for me with my first pregnancy. Lucky me. Now, z-scores are really great. We love to turn things into z-scores so we can find percentiles, and it's fabulous and it's wonderful, and we can only ever do that if we have an approximately normal distribution. If we do not have a normal distribution, we cannot do z-scores. So a key part is figuring out, hey, do I have a normal distribution? Now this is super tiny on the AP exam, so I'm not going to devote a whole lot of time to it. So I'm going to show you how one would do that, but letting you know that one rarely does this. Okay, the first method is what they call look and see. For this method, I would graph the histogram and I would be like, hey, is that unimodal? Is that look symmetrical? Then it's probably approximately normal. This is the second one. Doesn't match the empirical rule. I'm going to be honest. This is so much math, I've never done it. But I wanted to show you how one would do it if one wanted to waste time in this manner. So I could take the mean and add one standard deviation to it. So here's a sample mean and standard deviation, and then I could find what that range is, and I could find how many values are in that range and be like, oh, like that's 76% of the data, and two standard deviations, that's 77. That's pretty close to the 68, 95, 99.7 rule, but nobody's got time for this method. The one that's most commonly done is calculating a normal probability plot. And for this one, I'm just going to show you on the TI-89. You can look for the 84. You can look it up on the 84. Basically, what you need to do is go to Stats List Editor and hit F2 plots, normal probability plot, and then you input whatever list you're trying to do. And then you just hit zoom on the data. This is what a normal probability plot should look like. And if everything's normal, you're seeing a nice straight line. Here's not normal. If I were to draw a line here with most of the data, you would see that all of these are heading off towards the right. That's because it's skewed towards the right. So this is not normal. This is what the normal probability plot would look like on your calculator, and another one with Fathom. For the most part, you will never have to draw a normal probability plot, nor will you ever have to do one on your calculator. I have not seen an AP exam question that asks you for this. I have, however, every 3 or 4 years seen an AP exam that puts up a normal probability plot and asks you, is this normal? That's pretty much the extent of what you need to know with normal probability plots, or even assessing normality. Is they'll give you a plot and they'll be like, hey, is this normal? And you'll have to be like, well, is it on a straight line? Sure, it's normal. Otherwise, no. I don't anticipate that this is something that you're going to see. They have diminished it greatly on the AP exam, but I thought I'd prepare you nonetheless. Most of the time when you see a problem, they will tell you this is approximately normal, and then you know that you can use a z-score. And that's it. Have a great day.